Welcome back to BAS 121. Got a great question from the help forum on example 10.11 in the book and how it relates to the figure 10.12. So in this problem, we're taking the tabular computer sales set, which we're given, one of the data sets we're given, and we're given weeks in units forecast, and we're asked to take a look at some different exponential smoothing techniques at different alphas. So I went ahead and went to our XL minor and went to our smoothing and went to exponential smoothing and put in an alpha of 0.2, and I got this feedback here, as you can see. Number of records, there's my alpha of 0.2, and this is what it gave me for a fitted model. There you can see the weeks, the actual, the forecast, and the residuals, and a little plot. And then the question centered around some of these error metrics. Let me slide down a little bit. MAPE, which is our mean absolute percentage error, which means this is on average 32% error. So it's not a great model. MAD is our mean absolute deviation, and MSE is our mean squared error. They're all different, slightly different twists on how to measure the error of your forecast model. And the question I got was, there was some question as to how the mathematics worked and how these were calculated. So if you go back over here to the sales, what I've done, and I'll give you this file, is I've copied over the output from the exponential smoothing at an alpha of 0.2. So here you see the weeks, the actuals, the forecast, and the residuals. So if we're doing a mean absolute deviation, all we do for that one is we just take the difference between the actual and the forecast, which they already give us the residual column. So I just took the absolute value of the residuals, you see, for each cell. And then down here I just summed them up. And then here I just divided by the number of observations, or the number of forecasts we have, which is 16. And notice I get the 17.15, which matches this number right here. So I think we're okay. To go through the next calculation, which is the mean squared error, it's very similar calculation, except now I take my residuals and square them. Again, I'm going to sum them all up. And again, I'm going to divide by the number of observations, and that matches what I had over here, the 390. The last one, the one that's probably the most frequently used, depending upon who's doing, is the mean absolute percentage error. So what percentage is my model off? So for this one, it takes the residual and divides by what the actual off. So notice this one was off basically 100%. And it takes the absolute value of these percentage errors, again, so the pluses and minuses don't offset each other. Again, we sum all of these up. And again, we divide by the number of observations. And then we just multiply by 100 to put it on a percentage basis. And notice that 32% matches that percentage right there. So hopefully that helps answer the question. Thanks again for using the help forum. Hopefully you're finding it valuable. Any other questions, let me know. Thanks, and have a great week.